Determining the domain and range of a graph requires that we be thoughtful about the allowed inputs and outputs of a particular equation. Here we have a really simple example, y equals 2 plus 3x. You probably know from your previous experiences in math classes that if we were to graph this, it would take the shape of a line. This is what we call a linear function. But that's not the first thing you learned about this particular equation. It is likely before you started graphing this equation that you did something like making a table. So you would pick a series of x values and you would say x is equal to 0, so y would be equal to 2, and x is equal to 1, so y would be equal to 5, and x would equal 2, and y would equal 8. And as you created this series of values, you would place those points, plot those points on the graph, 1, 5, and 2, 8. And then you would hope that you would find some kind of discernible pattern between those inputs and outputs. We would call these numbers the inputs, they're the domain. We would call these numbers the outputs, they're the range. And we would map one of those numbers to the other one. 0 maps to 2, 1 maps to 5, and 2 maps to 8. And as you develop that skill more and more and more, the hope was that you could create these very obvious patterns that you could notice would be connected. Now, that's all well and good when you're talking about a linear function, but we really need to start concerning ourselves with domain and range because plotting points is not sufficient moving forward. Looking at just a few spots and hoping that those few spots can tell you everything you need to know about a function is just not going to work. You could imagine a situation where instead of these 3 points going this way and the line continuing down, we just looked at in the last lesson all of the absolute value functions. What's stopping us then from having a graph that's going to go this way? Just because we happen to pick these 3 points that follow that pattern doesn't mean that the remainder of them are going to follow that same pattern necessarily. We knew that with linear. We knew that if we got a line shape, we were good. But as we go to more complicated types of functions and more complicated types of graphs, we don't have that kind of assurance. So we want to do some thoughtful work regarding the domain and range of any function, knowing the kinds of numbers that we can test. Now, will that always solve the problem of the shape? Of course not. If you're not familiar with the different kinds of graphs, you're not going to get the shapes automatically. But the more and more we work with domain and range, the better idea we can get of what a general form might be for any kind of graph. And as we do this work, you're going to see that sometimes graphically is the best way, something like drawing a line, drawing the V, and that sometimes a little bit of thoughtful work with these equations can save us some serious trouble when it comes to graphing.